If you open up its learning, there is something called Quiz Lecture 1, Earth's Resources, and it's going to go right along with what we're talking about here. Is there anybody who can't find that? Everybody got that? Quiz Lecture 1, Earth's Resources. There's like 3 questions on it, I think. It'll go right along with what we're going to talk about. We're going to start a unit here on Earth's resources, and we'll talk about our use of those resources and kind of what they are. This is a picture that my buddy Jocko took. It's kind of a famous location in the United States. This is Centralia, Pennsylvania. This is his truck back here. So he's driving across country, and he stopped here just to see it. That is the actual highway right there. There used to be people living in this town. In fact, I think there's still like 10 or 11 people that still live there, even though the government evacuated everybody from this town. Yeah, serious business, right? What happened was they had a landfill, and at the landfill, something caught on fire. Somebody was burning some trash or something like that, and it caught the coal on fire, because Centralia is a place where we mine anthracitic coal. It's very high-grade coal. It's buried underground, and the fire caught the coal on fire, and the coal continued smoldering underneath the ground, and it would pop up in random places and burn the whole forest down. It could just pop up under your house and burn your house down. In fact, once it burned out an area under your house would just collapse. It gets so hot that the road would just crack. So this is a number of years ago, but it's still on fire, and there is no way for us to put it out. It looks like apocalyptic. Like you'd expect zombies to start walking across the ground there, right, coming after you. Doesn't it look like that? But this is actual coal smoke coming out of this crack in the asphalt right here down the highway. It's toxic to be there. Like you can't breathe the air because the coal is burning all around you. Not to mention that everything's burning down constantly. And you don't know where it's going to pop up next. But we've been unable to put this fire out. And I think, as far as I know, it's still burning underneath the ground. Yeah, we don't know what to do about it. But so we use the Earth's resources, and sometimes we screw it up. You know, sometimes we do good, sometimes we don't. But Centralia is sort of an example of just about everything going wrong that could. But yeah, there's still a few folks that live there. So let's dive into our resources here. There's 2 main types of resources, and this is the answer to your first question here. Renewable versus non-renewable resources. Not a very difficult thing to understand, but a lot of folks don't grasp the whole, like the length of time we're talking about here. Renewable resources can get replenished. It can take a long time, but it's like human lifetimes. Over the course of human lifetimes, we'll see new trees grow. Right? We know, I mean, it might take longer than you are going to be alive, but we can grow a new forest, and then like your children or your grandchildren can use the forest. So that's a renewable resource. Even though it doesn't happen fast, it happens in human lifetimes. Okay, so things like forests, trees are renewable resources. Water is a renewable resource. We could pollute it really bad, and it would eventually clean itself up if we left it long enough. Air is a renewable resource, right? Non-renewable resources, conversely to that, take millions of years to accumulate. And millions might be too small of a number. Like tens of millions might be a little bit better of an estimate for some of these things. Maybe hundreds of millions. When we talk about coal and oil and all those petroleum products, they don't just form in a human lifetime, or 10 human lifetimes, or 20 human lifetimes. We're talking about vast periods of time that nobody can wait for more to form. So in a sense, we've got what we've got. It's all we have on the Earth's surface, and those are non-renewable. Okay. So taking the scale there a little bit. Let's talk about fossil fuels here real briefly. So fossil fuels are any fuels that you can think of that are like petroleum, oil, coal, things like that. They're called fossil fuels because they're essentially the remains of plants that fell into swamps and didn't decompose and got buried for hundreds of millions of years to give us coal and oil and natural gas. And those things are really useful. They're very, very packed with energy, and we've pretty much made our whole society based on this type of fuel. It's high time that we kind of change that we move on to a new technology. This technology, burning fossil fuels, is ancient, right? Think about how far technology has progressed up to this point. Like we have things like iPhones, microwaves. We've got crazy stuff that's like very sci-fi in many ways, right? But we're still running our world based on fossil fuels. That's backwards. Like we need to upgrade our system, right? We need a major reboot. So fossil fuels, they work, but we found that they're really damaging our ecosystem in a bad way that's going to affect all life on Earth. So here's a typical kind of setup that might cause an oil trap. We might have a layer of rock that contains water. It's porous, so this isn't an underground lake. It's just porous rock, like maybe some sandstone. Oil likes to float on water, and so the oil will rise to the top of the water here, and we can drill down, and gas is lighter than oil even, so the gas that comes out of it will float above the oil, and we can drill down and let off the gas and the oil with our wells and pump this stuff out. Right? That's kind of how it might look for an oil trap, where we would collect it. We also get oil from things called tar sands and oil shales. So those are rocks that aren't super porous, but they're porous, but they don't have high quality oil in them. It's harder to extract. So this is the type of stuff that we usually do fracking on. Fracking is pumping high pressure water down into the rock to crack it, so we can sort of slurp everything back up. It's allowed us to keep pulling oil out of stuff that we couldn't pull oil out of. Okay, so the fracking of this stuff it's allowed us to extract more resources from the earth, but it's also kind of screwed stuff up. And you don't really want to live someplace where they're fracking, because when they pump that water down there to crack the rock, oftentimes they crack the rock down into the water table where we're getting our drinking water. And then the oil and things like that start to leach into the drinking water. So that's not a very good thing, right? But it has allowed us to get more, even though it's running out. It's allowed us to get more oil out of rock we could not have normally got oil out of. So it's been useful for us. We also use minerals. Think about all the minerals that are making up your computers right now that you're working on. That stuff has to come from somewhere. A lot of it is rare, so there's not as much of it. Things like gold and silver and platinum, those things are in your computers, and we need them. And there's only so much of them. So these are non-renewable resources for the most part. Okay? But any useful metallic mineral is called an ore. Okay? Here's an example of how we might get some ores. We get some hot water. We get some faults here. We've got the igneous pluton down below. And that water seeps its way up and deposits things like gold and silver and stuff like that in veins and mountains that we can then go mine, right? So that's a typical way that we might get a deposit of something like that. So those are deep under earth, and we've got to pull back the earth and dig holes to go find that stuff. We also use non-metallic resources, right? And there's lots and lots of those things that we need for their specific chemical properties because they're reactive in some way. Here's a whole list of different minerals that we've discussed and some of the things we use them for. For instance, we talked a little bit about garnets. We use them in gemstones sometimes. They're actually sandpaper. That's where we get our sandpaper. Make it out of that. Clay minerals, kaolinite, we make ceramics out of, right? There's lots of stuff that we utilize from the earth, right? It's not necessarily metallic. Okay, diving into solar energy. So, advantages to solar energy. Here we are. Two big ones. First of all, the sun's energy is free. This is the answer to your next question if you're not paying attention. Okay, the sun's energy is free. And secondly, it's non-polluting. It doesn't cause pollution. Solar energy is a fantastic thing. Totally free. Sun's up there fusing away, and it doesn't cause more pollution. Okay, those are the two big advantages of solar energy. Okay, once you get that typed up, click on to the next question, because we're going to keep talking about that. Okay, let's discuss one of the problems with solar energy, right? Even though it's free, solar energy thus far has remained very expensive. Okay? Prices have come down quite a bit, and you'll see more solar panels on roofs and things like that. But right now, we have to mine specific resources to do it. So in some sense, it's not completely pollution-free. And secondly, it's expensive to make all those solar panels, and they have to be replaced. Like, they don't last forever. So as a technology, it's phenomenal, but it's still got a long ways to go before it's going to be really, really useful. And it's getting there. It really is. Everybody see that on the next page? We're listing some of the problems with our alternative energy sources. Because let's be real, right? It is, as far as coal has gotten us this far, in oil and all those things, they have lots of problems. Fossil fuels have tremendous problems. But it's not that alternative energy sources are free of problems, right? Every energy source we use has issues involved with it. It's just a matter of picking the thing that is going to be the best for our particular situation. Let's talk about nuclear energy. Has anybody ever visited a nuclear plant? They're pretty interesting. In many respects, nuclear energy might be one of the ways towards the future here. Now, it's scary because nobody wants one in their backyard, right? Because what happens when they melt down? Like, everything and everyone dies, right? So they can be very dangerous if they're not regulated properly. We certainly would want to just open it up and say, hey, anybody wants to make a nuke plant, just go right ahead, right? We would want some government regulations on this stuff. Also, the problem with nuclear energy is, what do you do with the spent rods? When you're done, where do you put that stuff? What do you do with it? Because it's very dangerous waste. And right now, I think the US stores them underground in a salt mine. Other places like Japan dump them off the ocean in deep sea trenches. I'm not sure what Russia does with them. I'm pretty sure North Korea just puts them underground. But yeah, nuclear waste is a problem. In fact, so much so, I think it's Bill Gates right now is trying to, one of his sub companies that he's funded, it's never made any money, but it's an idea that they have where if we could use some of this spent nuclear fission fuel to continue the process of making energy, we could maybe deal with some of the waste and make it so that there's less nuclear weapons, because the waste from this stuff can be used to make nuclear weapons. So there's multiple problems with using nuclear energy, right? But it's very, very clean as long as we can deal with the waste. Okay, it doesn't cause pollution in the way that, say, carbon does. But you got that? Okay. Here is a nuke plant right there. Notice that it's on the water. Do you guys know why they're on the water? All nuke plants are always on the water, because what happens is, as those uranium rods heat up, as fission's occurring, they get really, really hot, and if you don't cool them down, the entire plant melts down. So that water moves in there and cools the rods. Now, it doesn't actually become radioactive, so the white wastewater coming out of that is bad for wildlife in that it's hot, but it's not radioactive. Okay, it's just cooling the rods as it goes through. It doesn't actually, I don't think it even comes into contact with the rods themselves. It cools the surrounding stuff. I think that one's out in California. Okay, let's talk wind energy. Okay. Wind could meet up to about 5 to 10% of the country's energy demand in the future if we get it right. Wind is incredibly clean stuff, right? It's free also. Now, what do you need? You need a place where it's windy. The other problem with wind power is that it can be kind of noisy. As those big turbines spin around, it can make a lot of noise pollution that people don't like, so they don't really necessarily want them in their backyard. And these big, huge wind farms can make quite a bit of noise pollution. All these stories about like wind farms killing off all the birds and things like that are not entirely all that true. It's not that birds never hit the windmill on that thing, the blades on it. It's just that it's pretty rare, and they develop methods of keeping them from actually running into them, right? I can't remember if it's the 3-blade ones or the 4-blade ones. I guess the 3-blade ones are better for wildlife. There's less often do they hit them. But yeah, it's not like there's not mountains of dead birds underneath these things like social media might have you believe, right? It's much, much safer than that. So wind energy can be kind of noisy. There's a wind farm. I'm sure you've driven past a wind farm. They're cropping up kind of all over the place. As you head north in Indiana, you start to see more and more of these things. They're much more common. It's a cheap way to make a whole bunch of free energy, essentially. Hydroelectric power. Okay, so hydroelectric power, in order to create hydroelectric power, we need to dam up an area and release the water slowly through it. Okay, so what this can do is it can actually really cause changes to the water temperature and impede the movement of different species. So this is not a dam in the ocean, this is a dam across a river. And because the water comes out of the dam at the bottom, the water after the dam is always freezing cold because it's the bottom water. Well, think if you're a fish that lived downstream from that dam, you can't live anymore because the water's the wrong temperature. If you're a crustacean or whatever else you are living in that water, it's suddenly very different. Okay, so it can, and of course it keeps fish that are upstream from ever moving downstream or downstream from ever going upstream because the river is dammed, right? So this is a dam that's on a river, not the ocean. And the problem is that it can change water temperature, it can change water purity, like how cloudy it is, the turbidity, and it doesn't let species move through them. Dams are kind of horrible for the environment in some ways, even though they are a cheap way to produce a lot of non-polluting power. Here's a hydroelectric dam, the Glen Canyon Dam. Look at that thing. All this water back behind there used to be a river, and it's now dammed up by this dam. And then down below this, you can't see it's a little dark down here, is the river continuing again down below. They're really beautiful feats of, human construction, but not so great for the environment for sure. Definitely we're changing it. Geothermal energy. This is probably one of the cleanest, most fantastic forms of energy that we can use. The problem with geothermal energy is you have to have the right geology. You can't just stick one anywhere. We can't stick one right here in Indiana, right in Columbus, because there's not a hot body of magma underneath of us heating the earth. So the big problem with geothermal is that they're only useful in certain areas. Okay. Iceland is almost entirely run on geothermal energy. And it is the cleanest country in the world as far as its energy footprint, pollution-wise. So they drill down into the ground, they find hot water, they pump it up, they run it, they use the steam from it, and they turn turbines. So exact same technology we use with coal, only there's no coal. It's just heated right from the earth itself. So super, super clean. The only issue is that you can't do it everywhere. You have to be lucky enough, like Iceland is, to be sitting on top of, well, a hot spot on the Earth's crust, like volcanoes, right? Here's a picture of some geothermal energy. Okay. I think that's actually in Iceland. Geyser is a location in Iceland. I never got to visit it, so I don't know if that's what it looks like, but yeah, there's loads of geothermal plants all over Iceland. They power their whole country that way. Tide power. This is an interesting one. And I almost got to visit one of these in Iceland. I didn't get to go down there. There's not many in the world because you need specific conditions to pull it off. What you do is you build a dam across the mouth of an estuary or a river, and as the tides come in, the tides, in tides, they come in twice a day and they go out twice a day. As high tide comes in, you have the dam open. Okay, and it fills up water behind the dam, and right before high tide goes out, you close all the gates on the dam. So you've dammed up all this water, and then you release it slowly out the bottom to spin a turbine because you've created a bunch of essentially what's called hydraulic head. It's a very free and non-polluting way to make energy, but once again, you need the right coastline. We couldn't build one of these in Indiana. We've got no coastline. Right? You need high tides to pull this off. Here's what they kind of look like. Right? So you got this bay here, low tide. You let high tide come in, you open up the dam, it fills up. Right before it goes out, you close it, and then you let it out slowly to run your power. to run the turbine. Okay, that should complete the quiz. You guys can put your laptops up. Oh no, sorry, keep them out. We're going to go on to the next thing here.